Welcome to the Anti-Pattern Podcast, your ticket to the revolution in digital thread technologies. Please welcome, live from Mannheim, Germany, your hosts, Christian Muccio and Michael Fenning.
Very, very good, and welcome again to the next episode of the Anti-Pattern Podcast. Together with me in downtown Mannheim is again Christian.
Hello.
My name is Michael, and today is all about theory to practice. Let's see. So what is today's topic? We have been approached by people asking us, what is it that you're looking in people that want to work with you in terms of hiring or in terms of partnering up with, right? What do people need to bring to the table in order to solve the problem that we are working on, right? In other words, what is it that you need to bring to the table to solve the problem of the digital thread? Right. And so we have been discussing that in preparation for this episode. And we came up with, let's say, a small framework. And that is theory to practice, right? From what I've experienced over the last years, the good practice people are also the ones that understand the theory. Usually, there are some exceptions to the rule, but usually. And my strong belief is there's usually some misunderstanding, right? The theorists, they say, "Oh, I'm so good at theory, and someone else, please do the practice, right? Implement it. What I'm telling you, and then please go and implement it, right?" This is one of the things that you can encounter, and the other way around, some of the practitioners will say, "Oh, they completely disregard the theory, so to say, right? And they say theory is not important; it's all about the practice." And our understanding is no, it's actually a problem of why do you need to pick, right? It's theory and practice, right?
Yeah, absolutely. Yeah.
And that needs to go together. There is this quote from Steve Jobs who once said, "The great thinkers are also the doers," because in the doing part, you learn again for your theory, right? And can prove it, right? Or verify at least, right?
Yeah, and most people we know who also went the way after university, doing a PhD, working as a research assistant, they all some kind of never stopped in theory.
Right.
Most of them I know, absolutely most part of the people, they never stopped at theory. They also went to practice.
Yeah.
And really, it starts when you're realizing it. What you thought about before years long, and the opposite is also true. So great practitioners are very often also the good understanders of the theory. Yep. So it's very seldom that you have maybe an implementer on customer projects or something with people realizing and implementing really good solutions without knowing the theory. Yep. But that's the minority of people.
Yeah, the great people know both sides. Right?
Exactly.
But if we talk about the not so great people, right? So what can go wrong, right? There is the one side of the story where people are only theoretizing, right, and never really implement something. That kind of people, they have one big problem. They never really see the reality that comes after theoretizing, right? Building some theory, and then there is no feedback, right? They still believe the theory is great, even if reality would disprove it, right? This is the one problem you can have. And the other problem is some people will say, well, I don't need the theory. I just do what customers will tell me, right? Could also be a problem, especially. So my feeling is these are the ones that actually don't understand the theory, right? Yeah. So, and both of that is something we don't want, right? We want people having a great foundational understanding of all of the theories that you need to have to realize the digital thread, right? And are also good at doing, right? So both needs to come together. And what we wanted to do today is, so what is it in terms of theory? And we save the practice part for next time. Next episode will be about, practical, best case practices, things we learned over the years. Today is reserved for theory. And what kind of theoretical concepts do you need to look at to work together with us, right?
Especially in this early phase.
In this early phase, yes. So we came up with a list again of things that are necessary. And Christian, what is the first thing?
So the first topic is definitely data modeling. So what we did and realized in the last 6 months, 7 months now, is mainly around data modeling. I think we talked about it, that the modeling engine is the thing we are working on, and the user interface preliminary and one. It's all about data modeling, and therefore it's also interesting or very much appreciated if people who want to help us also know about meta modeling. And meta modeling is even one way more abstract, one flight level above the modeling that is already there, and that many people know from other PLM experience maybe. Because we are building up our own meta model first. That was our first task. Building our data model on top
of data models, even more than just one
models. Exactly, and even in data modeling, there are plenty of concepts you should know. You should know the difference between an association and an aggregation, speaking in SysML, UML terms. Right. Inheritance. These are basic features of data modeling people have to understand. And it gets even more complicated, worse, I would say, when you, let's say you distinguish between structure and behavior. Because then you're very quick in the field of semantics. Right. What are semantics? What are ontologies? Building up semantics. This is very important for us, especially because this is one of the features where our data model will be a little bit different from the data models you have in solutions nowadays on the market. And there are many, many more things. So if you know the model-driven architecture from the OMG, it's definitely helpful.
It would be helpful, definitely.
Because everything is data-driven in our system and model-driven in the end. So I think this is a thing of low-code, no-code platforms, that you hard code as less as possible.
True. Yeah. To be generic, you need to understand what a meta model is and how meta model relates to data models. And this is actually a good example where you can show what is practice and what is theory, right? So we need a meta model, we need a data model, definitely, right? And in practical terms, the solution needs to be easy enough, right? That many people can understand, because then you can scale it, right? What is more in the theoretical world and never really made it to practice, in my view at least, is if you have above the meta model a meta model and then a meta model, then things getting crazy, right? And this is something you cannot that easily explain to anybody in the world, right? So, and then you have a huge problem with scalability because the learning curve is too steep. Right, so you need to look into the theory, and sometimes people over theorize things. Right, you need to get the gist out of it, right, the best stuff, and then make it reality. Right, because only easy things can be really easily realized, because you need to have a lot of people understanding it.
Yeah, sure. And even in our case, many of the things we are doing now will be abstracted away, even for app developers in the end. So they will use it as functions, as modeling elements, and the meta model behind it's abstracted away.
Yeah, exactly. Yeah, and so the second thing is, I guess, easier to explain, and that is you have to have a good working knowledge in science, right? Because from what we do, at least in the beginning, right, everything is basically based on science, on scientific understanding, on the scientific method, right? Again, you have a theory and there's reality, right? And then if you find out that your reality is unfortunately disproving or making some flaws obvious in your theory, then you have two choices. You can stick to your theory and say, oh, the real world is stupid and I want to have it differently, right? Or you can, take the pragmatic approach and say, well, if my theory is not good enough to describe reality, then maybe I should work on the theory, right? So this is definitely something you learn if you are exposed to scientific working, right? And the other thing is, of course, all of that stuff you learn in physics, right, in chemistry to some extent for us, right? Our customers are usually hardware companies, right? You need to have a working understanding of what they are doing, right? If it comes to mechanical engineering, right? If it comes to process engineering, right? All of this is based on science, right? And if you don't have a working understanding of science, at least in the phase we are now, right? We are now in, you would not be that helpful, right? You'd have to have some basic foundational understanding of what science is, right?
Yeah. And speaking of science, I think in the phase we are now, and the theory behind it is that we think that we will have many nodes and very much more edges
In the graph.
In the graph.
Yeah.
Is that we somehow have to deal with it also from a performance perspective.
Right.
And therefore, for us, the understanding between electronics and information technologies or computer science
Yep.
gets important. And it's funny because my diploma thesis was about calculating traveling salesman problems on GPUs. And this was 13 years ago. And I never thought that I will use this again.
Okay.
And now we're sitting here.
Lucky coincidence, you worked on this before, right?
Absolutely, yeah. Thinking about performance, thinking about what does some modeling mean for computational tasks our platform has to do.
Right.
What does it mean to traverse a huge graph, which might end up in a GPU because a CPU is just too slow for it.
Yeah. That's something that that you learned, right? And I'm learning it from you, right? Because I was never that electronics guy, to be honest. Yeah, but interestingly. And the next thing, talking about processes, right? So industrial processes. My understanding, hopefully it's still valid to say that in Germany we didn't do at least one mistake that others have been doing in the past, and that is get rid of our manufacturing industry, right? It proves to be actually a problem, at least in my view, right? The UK and the US, what they did, moving the manufacturing out of the country was probably a mistake, and in Germany we did not do this mistake.
Not in that extent.
Not at that extent, yeah. So in Germany we still know how stuff is manufactured, right? And understanding how manufacturing processes, engineering processes for hardware, right, and change and configuration management of such systems, right, is working, is something that you can learn, of course, in theory, right, in the books, right, and you can read those books all over the world, right? But in all of the details for certain industries, for certain companies, this is luckily some knowledge that we preserved in Germany, right? And this is really something I would say is an asset, right, in Germany. And understanding those kind of processes is important because this is the processes that our customers will run with our software, right? So if you don't understand those processes, you cannot talk to them, right? You don't know what is it that they talk about, right, when they want to use our tool.
Right.
Yeah.
Yeah, and speaking of processes in the manufacturing or in the industrial world, also processes in the software world are extremely important for us in this stage we are. Not that we have our own development process and software development process and procedures how to version and release things. This is also important in the end for our platform, how the customer's data is being handled. Okay. So somebody helping us will definitely have to have knowledge about how is software versioned. You have to have a basic understanding of Git, what a commit is, what a tag is, what branching and merging means, and what it does. Because, and I don't know if we ever talked about it, but our platform will have a, let's say, Git-like versioning mechanism under the hood.
We talked about this when we were talking about what influenced us.
Oh, right.
Git
exactly.
is definitely there.
Yeah. And other software processes are definitely CI/CD pipelines. It's not only that we need it in our software development. I recently talked to Josas from Seaside. And he's proclaiming a very, very interesting mechanism or procedure or process for MBSE, saying, and I hope I tell you this in the right way, that the what was it? The textual notation of the SysML v2 enables MBSE processes to be run in a CI/CD pipeline.
Yeah, I see. Yeah, sure. Because it's usually text-based, right?
Exactly. It's text-based. You can trigger any downstream processes, maybe manual processes, maybe automatic processes, like a simulation or so.
Yeah.
So CI/CD is not only software stuff anymore.
Right. And one thing that I would like to add, software stuff, is of course, if you get a bigger team, right, it's not so important for us in the moment, right? You need to have some kind of development process as well, right? How do you turn a feature, right, that was, specified together with the customer, hopefully, right, and then broken down into issues, right, and then how you, bring it to reality? That kind of process is also, in theory, you need to understand what agile product development means, right? Usually, if you only look into the theory, or what many developers do wrong is they take the rights that you get out of it, right? Because it's a more decentralized decision making, right? It's not that one decides what everybody has to work on, right? But what they forget is the responsibility that comes with it, right? So if you really run it in the real world, an agile development process, be it safe, be it something else, be it just Scrum, whatever, right? Doesn't make a huge difference, right? It's important to understand. Don't just take the rights you get out of it. Also be sure that you handle the responsibilities, right? Because you're responsible in the end. So if decision-making is decentralized, everybody is responsible, not just one guy, right? And this is sometimes a little hard if you only heard about it in theory and never worked in a huge development organization in practice, right? So this comes to that as well. And,
Yeah. Another example, a very good example we discussed in the last weeks in our development meeting was what does branching mean to a mechanical engineer? So even if our platform is able to branch a part, you never can name it branching in front of a mechanical engineer. But you could name it design alternative.
Right.
So that people are able to try out different designs and merge the best one back into the main branch, so to say.
Yep, exactly.
This is absolutely interesting to see because now we might not be the first ones, but what influences us much is what can hardware processes learn from software and what can software learn from hardware processes.
And vice versa. Yeah, there's good stuff out there, and usually same concepts exist, but they are named differently. Exactly. And so talking about software, as we are a cloud native company, and the tool is built on cloud native technology, one of the things I learned a couple of years ago that you need to look at in theory is the CAP or the Brewer's theorem, right? CAP stands for, or help me with that, consistency, availability, and partition tolerance, right? So, and a computer system can never be all three things at once, right? You always has to pick 2 over 1, right? You can have a CA system, you can have an AP system, right? Or a CP system, right? And that actually, if you dive into that topic, you understand how you need to design architectures for distributed computing, right? And that helped me also to understand what that means for scalability, right?
Yeah, for microservices.
Microservices, for example, right? And that is something that I looked at couple of times already, because if you design the architecture, right, you need to understand what is the drawback of doing something like, A, and then you have some drawback usually, and this is, this needs to be balanced out, right, from an architectural perspective. Yeah. But it started with theory, and it's, I guess, even a mathematical proof, right? There is some mathematical proof that you cannot fulfill all 3 dimensions at once, right?
Yeah, that was something,
Yeah. Right.
Yeah, speaking of capped theorem, which is applicable for databases, also database technologies are a crucial knowledge for our partners, for our developers in the early phase, because most of people, in the not in the world, that's wrong, but most people in software development know SQL, classic SQL. Table-oriented,
right,
joins, and so on. This is definitely helpful to have this knowledge. But we are going one step further. We talked about it plenty of times that we are implementing the graph as a graph. So and developing managing graphs in SQL has its limits, and these limits are met very fast. So that means we need to go to NoSQL, and NoSQL is a whole class of databases.
Yep.
For example, even document-based databases are working fine for us at the moment.
Right.
Nonetheless, this basic understanding of graph theory and then afterwards graph databases, whereas they also distinguish between from disk, in memory, and there are so many different even graph databases. So NoSQL is again a whole class of databases, but just having the interest in this technology and the basic understanding, and also the more specific understanding in single database implementations is very helpful and is absolutely required if you want to be part of this core team.
Yeah, and I think it's crucial to understand that there is not this go-to database technology that you can pick from the shelf. And you always use this, right? This is the one way to look at it, right? There is this multiplicity of different technologies summarized by NoSQL, right? And you need to pick the right one for the right problem, right?
Exactly, yeah.
And it will also not always be graph database, right? Even if we say, the relationships and not the complexity that we need to handle, potentially this is going to be a graph database, obviously, but there will be others as well.
Absolutely, and some of the problems will be solved by a table, by a classic SQL best. Others will be solved by time series databases.
For example.
Maybe we even need key value stores for performance reasons.
Right.
So this is also very important for us to be agnostic. But the graph database will be the core component, I guess.
Yeah, definitely. And talking about graph theory, also the question, what is the difference between a directed and an undirected graph, right? There's also mathematical theory around this topic, right? And you have to be very careful when to pick the one and when to pick the other, right? Especially when it comes to use it in graph databases and data model it, right? The data models need to be, aligned with that decision that you do there. So this is also definitely something that we have been looking into. I remember this in university was part of operations research.
Oh yeah,
graph theory.
Yeah, that was the chair where I wrote my diploma thesis.
Yeah.
Was operations research.
Yeah, exactly. Yeah, and so other processes as well, right? And I picked one that is especially in our domain something that people have been trained with a lot lately. This is systems engineering processes, right? ISO 15288. The last version is 2015 still, is it?
No, there's a new one, 2022 or 3.
Oh, okay.
So I had David Endler in the MBC podcast
okay.
a year ago, or a little bit longer.
Yeah.
There was this new version, and he was leading it.
Okay, very good. Yeah, there's an update to it, so I'm still on the old version. But yeah, that's something that I learned years ago, and I got my certificate on it. And this summarizes a lot of things, right? Because it obviously brings together processes that you will find in hardware engineering, and maybe name it here and there a little bit differently, but you will find them, and in software engineering to some extent at least, and then to all of the other supporting processes that you need, right? And it gives a pretty good overview of what it means to design a system, right? Design and operate a system. Yeah. So the SE process is also something that you have to have some understanding of, even if in the end you don't work in systems engineering, and even if you work on an application that is not, MBZ modeling, right? Still, you need to have some working knowledge on what systems engineering is.
It's definitely helpful.
Yeah.
Next knowledge you should bring is, of course, mathematics and statistics. So, of course, we are developing a software. And computer science is coming from math.
Yeah.
In the end, it's math.
Yeah.
And so mathematical understanding is absolutely helpful. But with the emergence of AI, more and more also statistics, and also for all the data analytics stuff. Statistics are getting more importance again. I think that was different 10 years ago.
Yeah, true.
But these two skills should be on board.
You have to have a working knowledge in math, right? You have a mathematical mind to some extent at least, right?
And I think most engineers have this.
Most engineers will have that anyway. Yeah, true. And yeah, last but not least, and I summarized it by one word: business stuff. So we did not want to neglect, so to say, the theory that you also have to look into if you build a company, right? There's a lot of stuff you have to know, right? But to be honest, in the beginning, it's not so super important, right? Because the mistake that could kill us is usually we do a mistake in the software, we do a mistake in some legal issue, maybe, right? This could kill us immediately. But not having the best balance sheet, doing some problem or creating some problems in accounting, right? This will not kill us. This will create problems, right? So what I'm saying is the business stuff is important, but it gets more important over time. And in the beginning, it's not the most important thing to do, right? And what do I mean with business stuff, right? For now, I have to have an understanding of what it means to account for something, right? I have to be able to read our own balance sheet, right? Yes, of course. I need to be able to understand how company valuation works. That's discounted cash flow. What does that mean, right? Because once we have an investor, they will use those tools to understand how much money, they are able to bring to the table, right? And what does it mean for us, right? So this is something you have to have some working knowledge in, right? Marketing, definitely, right? And there is some theory around marketing, but marketing in the beginning is 80% practice and only 20% theory, right? So working knowledge, but most of it is something that you have to do in the real world, right? And then communication skills are important, right? But also something this will not, kill us, right? And then leadership skills, right? Even if we're just 4 people in the moment, right? We will hire people, and the more you get, right, the more you need to balance the teams, make decisions together, right? Make sure that everybody's on board, right? And that sounds easier than it is, right? This is way harder than you think. And something that I want to say, especially for Germany, is a working knowledge in economics, right? What does it mean when markets shift in a certain direction, right? What happens if the economy is in a downturn, right? And what options do we have then, right? In Germany, we don't have the best, working knowledge of economy, right? What we usually blame the Americans for not having any understanding of geography, right? Germany has no understanding of economics in our open public debate around this topic, right? So be sure that you know some concepts from the economical field, right? And then last but not least, also, under the business stuff, this is the one thing that I think if you found a company is mostly disregarded and not seen as important is psychology, right? Because leadership, you need to have some understanding of, how people work, right? People are not machines. That makes it harder sometimes, right? That is the one thing. And the other thing, all that relates to marketing again, right? If you want to convince someone to buy your stuff, right? Psychology plays a huge role.
Even internally. So the concept of the intrapreneur is applicable to any employee in our company later on.
Definitely, yeah. So this was the things we came up with for theory that would be interesting to have a working knowledge on, right? And then next time we want to talk about how can we make that theories reality. What are the the stumble stones that you could stumble upon, or the drawbacks, or how do you make it actually reality? Because in the real world, as I said, things need to be consistent, right? They need to fit together in a joint concept, right? You need to bring everything together and make it something concise, right? And it must be easy enough because you want to communicate on it. You want to find enough other people that understand what you're doing, right? So taking all of the theory and make it reality is not an approach to go, right? You need this theory, condense it in one joint concept, and then try to have it easy enough to make it
to life.
Bring it to life. Yeah, that's how it should work, right? And the second part is something we will look into next time.
Yes.
Very good. Then, thank you very much for listening in. This was already 20 minutes again, right?
More than nearly half an hour.
Oh, we jibber jabber. All right, then talk to you soon and bye-bye.
Goodbye.